Thanks, Jim. Hello, everybody. I'm Rick Hangartner. I work here at MyStrands, working in large part on the what we calling here the data problem, finding sources of raw data and deciding how to process them to generate the statistical domain knowledge we need for future applications of our recommender technology. It's interesting, and I appreciate the chance to exchange ideas, as Jim has said, with people there because we do think that technology-enhanced learning does present an interesting new domain area for applying social recommender technology, and in particular, the data problems there seem very interesting to us. So briefly, to launch into this, let's just define what we mean by the data problem. That is, really, we need raw data to build our statistical domain knowledge. So where do we get that data? How do we extract semantic information from it? And how do we actually show this information has meaning with respect to the recommendation problem that we're specifically working on? There are many approaches to acquiring data that are common in the recommender technology area, social or otherwise. Um, the first as explicit ratings, as you might be familiar with Netflix. There are other sources, observed interactions with target media artifacts, such as MyStrands does. And then there are also been, the last several years, many attempts at aggregating behaviors across new media forms to try and put together different kinds of recommenders that can use that data. Um, One of the most interesting places to look for experiments along those lines are the MIT New Media Lab, and I'm sure many of the people there are probably familiar with a lot of the work coming out of there. These different data sources, I think one of the most important things to be aware of, that they really do support very different types of inferences, and therefore then the recommendation you can make from the data, the inferences, the semantic knowledge you gain from them. So it is a real problem to decide how we show this information has meaning with respect to the recommendation problem at hand. Probably the other side of that, which some of you may be familiar with as you're working with recommenders in your applications, is that really the availability of the data types, the data and the availability of the types of data, sometimes can unduly influence how the application is built and what you think you can do with the application. I think the important thing to be aware is when that's happening, we really need to derive the semantics from our task from the data, not let the data determine the semantics, or we end up with a suboptimal result. So that really does raise the question, where is the meaning in the data for a particular recommendation task, and what does that even really mean itself? Well, first of all, what are semantics? That depends on the field what that even means. Computer science, semantics really are the relationship between programs and the results they produce. In linguistics, semantics really refers to the idea that a word or a sentence, a symbol like that, has a specific interpretation to an individual in a language. Philosophy and psychology look at semantics as something bigger, and that's really what the cultural or personal framing is evoked by specific words, signs, or phrases. We think for social recommender technology, we might usefully define semantics as information and data that's relevant to the recommendation task itself, which is actually a more sophisticated way of thinking about this than it might seem on the surface. There really are two questions that you have to answer when you take that approach. What really is the recommendation task, and how does the data available embody what you believe is the required information for the recommendation task? Looking at it another way, you might ask, how superficial or how easily derived from the data is the required information in the data? When you look at it that way, in some ways, technology-enhanced learning really does represent an evolutionary step in the application of social recommender technology. And we'll expand on that a little more as we go forward. One way we can better understand how technology-enhanced learning applications might represent an evolutionary step for social recommender technologies is to more carefully consider the superficial semantics of many of the data sets that are used right now to build recommenders. The superficial semantics of ratings really are about how users rate things. And we know that users approach the task of rating media items quite differently than the way most people approach the task of simply selecting media items to experience and enjoy. Popularity tabulations are another very common approach to building recommenders. And in that case, the superficial semantics really are about users' affinities for popular things. One doesn't have to work long with media items and media recommenders to understand that popularity is a social phenomenon that stands quite apart from many other aspects of the media items involved. We derive explicit associations from lists of items, and in that case, the semantics are about how users list things. One has to think very carefully in any particular situation on how these things came to be on a list, and I will give you an example a little bit later how the superficial semantics can sometimes be misleading of items on lists. Another way we build recommenders is to derive implicit associations from observed behaviors, and there one has to be very careful because the superficial semantics are about user behaviors in particular contexts. One can take iTunes as an example, where the play counts are very interesting and useful information. One just has to keep in mind that many people simply put their iTunes on shuffle for long periods of time. So in those cases, it isn't you can get useful information. You just have to be very careful to understand what's really going on. In all of these cases, there's frequently another level of analysis that's applied to the data to get another level of semantics, and that's factor or hidden factor analysis. Latent factor analysis is another term used. And there, the semantics are that you're imputing a certain number of causes for observed data. It isn't that you specifically understand or postulate the causes, it's just that you postulate that there must be a certain number of causes and then try to cluster or otherwise categorize the data as resulting from those causes. These examples really suggest why we need to think a lot more carefully about the meaning we attempt to derive from data we use to build recommenders for technology-enhanced learning applications, and really has commonly been the case for most recommendation applications so far. If we look at collaborative filtering, really the surface semantics are pretty straightforward and simple. If you like item X, statistically speaking, others also liked item Y, which kind of implies you might like item Y. A lot of the important problems in technology-enhanced learning seem much harder because there's a deeper assumption at work. And if we sort of schematize that, we might set up something more like a syllogism, which says if you've interacted in a new media through forms WXY in this way, statistically speaking, you seem to share a particular learning style or need, so you might find Z useful. This really requires meaningful integration of more diverse data in the first place, because learning is a multifaceted behavior. And it also means that we have to have a meaningful inference going on in the second step, which really does get to the science of learning and behaviors associated with learning. So it really does seem that many interesting technology-enhanced learning problems address much more complex problems than might be in just the common application of recommenders to recommending cultural media artifacts.